Hey everyone, welcome to our talk. My name is Will Sweet. I'm the head of product experience at Datafold, and I'm here to talk to you about a different way to work. So quick question before we dive in. How do you check your work currently? Do you do nothing? Do you write ad hoc SQL queries, maybe DBT tests or great expectations tests as part of your pipeline? So let's start at the beginning. A lot of people think that we start with a shiny new model, and that's not really how a lot of our work is done. We have to go back further before we get to the idea of even starting a model. Where are these questions coming from? What is our work actually doing? So it typically starts like this. Someone knocks on a door in some office in some different part of the building, and they ask a question. And that question typically pings around the organization kind of like this. It goes from marketing to sales to product to success. Maybe the engineering team and product teams get involved. Eventually, it gets back to data before finally analytics engineers and data engineers are getting involved in having to address the initial question. And as much as we want to think that our work looks like this, a very nice left to right diagram, it actually feels a lot more like this, a maze where we start in the middle and we're trying to figure our way out. And there's multiple ways, but we have to figure out which one is best. So how do we work our way through? I'm going to talk about three ways today. One is the ship it method. You've probably done this before, maybe not calling it this, but quickly making a change, making a push to production, and then moving on with your day. There's also the rabbit hole where you can try to predict everything that might happen and then actually go down and address each one of those things individually. And then there's this new way that we're talking about, which is this different way. And sorry for the bad pun. Where we use our open source product and our SaaS product from Datafold to actually dive in and diff the changes that we're making, not only to the code, but also to the data it produces. So let's set the stage with an example. Let's say we have this as our warehouse model. We have three of these upstream data sources that are flowing into a dimensional model for organizations that then gets fed into this finances team's monthly fact financials model, as well as a sales sync that goes and empowers the sales team. So in our example, we're going to swap out this signed in for org created. Basically, probably a scenario many people are familiar with, but maybe the org created event came after signed in event and actually has better information. And the finance team wants some of this newer information, some of these additional columns, and we're going to pull that in and pass that down to them for their fact monthly financials. So if we were to do this under the ship it model, it would look something like this. We would go into the existing model. We'd make our change, updating from signed in to org created. If you're using DBT, you might do something like this, where you run your DBT model. You see all your tests passing. Then you create your PR, and you're presented with the chance to merge. And let's say you do hit that button and you do merge. What you might be greeted with a couple of days later, something like this: the CEO reaching out saying, "This looks wrong," the dreaded dashboard broken scenario. And even with this, you might even have other teams get involved as well, because again, a lot of our work powers lots of parts of the organization. So you might even have the sales manager reach out and say, "Sales ops are down this week. Did something happen?" And both of these are dreaded scenarios for us as data practitioners. We never want to see this, because we want to have our work have a huge impact in the organization, but we don't necessarily want this kind of publicity within the organization. So if we're not doing it just the method of making a change, shipping it, and waiting for other people to tell us what broke, what's a more proactive method for doing this? And that's this rabbit hole method. Again, we're trying to predict everything that could happen and going down the rabbit hole to actually resolve all of those changes. So in this scenario, the beginning looks very much the same. You make your change, you build, you run your models, you see that everything checks out. But instead of just taking it at face value, maybe you dive in a little deeper. You look at your production table, this core dim orgs model, and you compare it to the development version of this table, what you've been working on the logic change for. And as we can see, there are 11 missing orgs between our what's in production and what's in development. That's obviously not good. That's going to break something. So maybe we look at this and we say, we can bring this in and seed this missing organizations into our model. I mean, by looking at the org IDs, it looks like they're all some of the earlier orgs. Maybe they were just in the sign up event, but not necessarily in the org created event, which makes sense. It happens. So we'll switch and we'll make this seed. So we create a seed file, we add that back in, we rebuild, retest, everything passes again. And we create the PR. And let's say this time, instead of just merging it in our own, we have maybe some better practices by having someone else review our work as well. And so we kick over to a PR review process where the person is greeted in GitHub with something like this, where they're just looking at SQL and trying to see whether the changes made in the SQL will actually have a positive or negative benefit. And looking at this, we probably can all say like, valid SQL, it doesn't look like it'll break anything. Maybe if I'm aspiring as a manager or reviewer, I might even pull down and rerun the test that someone else ran just to have that extra level of security. And again, we're given the chance to merge. And because we've done all this work, we do just that. But again, maybe the CEO isn't reaching out that the dashboard is broken, but sales is still affected by something. And we didn't catch it because again, it's hard to know what to look for in the output of how our data is consumed by all the other teams that sit downstream of us. And that's where diffing it comes in. So the different methodology is, again, looking at not just the changes to code, but the output that has on the data itself. And it sounds like you could do this by running a lot of ad hoc SQL queries. But as you saw earlier, there's so many things that sit downstream that it's hard to know. So again, we make the change, we maybe like run our tests locally and see again that everything passes. But instead of diving in, we might run something like this. So this is Datafold's open source product. We can specify the data warehouse we want to look at, the table we want to compare, again, our core DIM orgs model with our development model. And we can pass in the primary key of org ID. And as we run this from the command line, we can instantly see what's different here. And we can see that we're missing, again, those same 11 rows that we saw before. So nothing different than running the SQL query. And we have this information right from the command line, right from where we're running our dbt build or kicking off a build process. But we also have some other things we can add in here. We could pass in a stats flag and get some information. This is extremely useful. Again, if you have other, beyond just an ID, you have some values that you want to look at. From this, we can see what the min org ID is, which is that 00012. That's super useful, again, to know that only ones that are missing are those early like rows and organizations. We could even pass in something like this timestamp of created at, and we can see not only that there are 11 different missing rows, but we can also see with this red and green coloring that the timestamps have actually changed for even the rows that we do have in both databases. Now, this might be something worth looking into further. So I can pass in this -m flag for materializing this result into the database. And that's something that I can query here. And I can look at all the different scenarios we've laid out, what's different, exactly how it's different, and quickly get at what might be an underlying problem here. So again, let's say we don't really know how to account for this timestamp change. We don't know if it's having really any impact. We can create this seed model, again, rebuild and retest, go to a PR review process. And that looks something like this. We kick off that PR. And instead of having someone go look at a wall of SQL like the other otherwise might, we actually can generate Datafold printout within the PR itself. So again, in this process, we kick off a PR job. This is creating, again, a PR version of the table to compare to our production version. We again look at our SQL and we say, you know what, everything in here looks good. I don't see how this will break anything else. But as we wait for our PR job to complete, right now we're building those models in our staging environment or testing environment. That's done. Datafold immediately kicks off to look at all the changed models and compare the one in production to the one in development. And so again, we flag this DIM orgs model. We flagged that we have more columns than before, but we still have the same number of rows. That looks good. But what I didn't expect to see was this sales sync, where we now have two fewer rows in our development version than we do in our production version. And you can see that here. We dive into the Datafold app and you can see just that. There are 4 distinct primary keys in the table that is in production, and there's only 2 in the one that is in development. And if I look, I could see which 2 rows are missing. It's these 2 orgs, 135 and 138. I can ask around and figure out how this is used, but let's say I already know how this is used. It's what's feeding the sales team and who they're reaching out to each week to convert into paid users. So now knowing this, I can reach out to the sales team and tell them, hey, by the way, this week you might expect to see fewer opportunities to work, but here's the ones that you are missing. And if I wanted to go understand why and see if this is something that's just a point in time, or if this is something that will persist, I could go back to my dim orgs and compare the 2 that have fed into this subsequent model. And going through this without even looking at the SQL, I can see that the ones that I now have in development, the org IDs are now, or the created ad dates are now a couple days beforehand. And this might be because the org created ad event is fired before the signed in event. And now that we're capturing that initial value, we're actually getting to people earlier in the process than they otherwise might. So I can confidently say that this is probably something that's just a point in time. It's our time stamps kind of going backwards a little bit. But now from here on out, we should be good. And we actually should be reaching out to people sooner. It's a value add for the sales team. So again, we merged our pull request and our teams aren't mad at us. They're actually wanting to hang out with us and actually spend time instead of just critiquing our work. So let's quickly recap. The shipment method is pretty fast, but it has a high degree of false confidence. The rabbit hole method is arguably a lot slower. You're having to really know your data model in and out, but you're confident in the workflow, maybe sometimes a little too overconfident. And then you have the divot method, which is fast. It's, the ship it speed at rabbit hole confidence. And you have confidence not only in your workflow, but also in the downstream work itself. We encourage people to just look before merging, kind of what your parents taught you when they're teaching you how to drive. The same goes for when you're merging your work into production. And then a couple last things. We have this open source product, which we covered in brief, that we have within the command line. We also have a replication version of this, which can really help when moving data from Postgres to Snowflake. We can cover about 5 billion rows in about 5 minutes to validate that the data you expected to get from Postgres into Snowflake actually made it exactly how you wanted it to. So I encourage you to check out our open source project and encourage you to check us out with locally optimistic Slack. And feel free to email us at support or px@datafold.com.